Okay, for number two, this is a multinomial expansion, by the way. It's not binomial, it's multinomial. They want to know if the expression is expanded and simplified, how many terms there are in the resulting expression. I'm going to do the whiteboard and sort of like talk through it and put number two down. And number two is a multinomial expansion. And that's going to be A plus B plus C, and that's raised to the 10th power. Now you realize it's still, expandable. We could do that. I hate to see someone expanding that out, by the way. For example, if I took A plus B and 10 to the 10th power, I'd hate to see it expanded out, but you could do that though. You'd have A squared. I'm not going to worry about the coefficients, by the way. What's the next term going to be? That would be, I'm sorry, not A squared, A10. That would be A9, and then a B, and then the next term would be A8, B squared. The sum of the exponents is always going to be 10, by the way. The question is, if you keep doing this, not that I want to do it, but you eventually get to the end where there'd be A0, no A's, just like over here, there's no B's over here, and then it'd be B10. How many terms would there be? Well, just counting it up, it's 0 to 10, there'd be 11 terms. That's for a binomial, by the way. This is not a binomial, it's a multinomial. So the way I'm going to do this over here is a couple different ways of doing it, but I realize the terms, right, they're going to have a combination of letters in it. And I want to point out, if you thought about it, the first term would be, like A10, there would be no B's and no C's, right? But, you eventually, keep working along, and the question is, how many would I get of these things over here? And what I start to see is I start to realize that it's really, how many different arrangements are there of this going to occur? And the way I look at this over here is I know that there's objects here, all right? And those objects, there's going to be, let's see, 10 of them. Right, I'm just going to put them down as stars, by the way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me see if I counted it right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if I were to partition this one over here with this first one over here, I want to point out that I would say, oh, it's just 10 A's, this over here. But you know what? I could put another combination down. I could put this over here, A9, and then I'd put down, let me put A8, and then B1, C1. There's other possibilities too, though. So what would that look like? And I want to get my eraser out. And I'm going to erase this red line over here. All right, so that would look like 8. That's 8, the 8 A's now, 1 B, 1 C. So what I start to realize is that it's basically partitioning this, and it's a counting problem for me. Right, and this is one way to do it, and you may want to do it this way, all right? Now, how many objects do I have here? I have 10 of those stars and 2 of those vertical bars, and we're going to be moving things around, all right? So it's going to be 12 factorial. 10 of those objects are identical, and 2 of those objects are identical. This is a computational problem. What do you get? 12 times 11 times 10 factorial. On bottom, what do you get? 10 factorial times 2, because 2 factorial is 2. The 10s cancel off. 2 goes into 12 6 times. You get 66. That's one way of doing it. Let me do it another way, all right? The other way I'll do it is just relate it back to a binomial. So A plus B plus C squared, all right? So then the question becomes is what do you get over here? I'm not squared, it's 10. Well, if you thought about it, I mean, it's a binomial expansion. You can get A plus B to the 10th power, no C's. I'm not worried about the coefficients, by the way. What's next one going to be? A plus B to the 9th power times C. What's next one going to be? A plus B to the 8th power times C squared. And you get yada, yada, yada. Oh, at the end, you get A plus B to the 0 power times T to the 10. Now, if you were to count the number of terms here, what would you get? 11 terms. If you count the number of terms over here, what would you get? There'd be 10 terms. Again, binomial expansions are much easier. What do you get over here? 8. then you're going to get 7, then you're going to get 6, then you're going to get 5, and then you're going to get 4, then you're going to get 3, then you're going to get 2. Where's that coming from? That's coming from the a plus b to the first power times c to the ninth. There'd be 2 terms there, by the way. The last one's going to give me 1. So now I got to sum of the digits, right? 1 plus 2 plus 3, yada, 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 up to 11. Well, that's going to be 11. It's n plus 1 is 12. Whoops. Get my eraser out. Erase this over here. Again, sum of the integers from 1 to 11. Let's go back over again. N, 11. N plus 1 is 12 over 2. 2 goes in as 12 6 times, 66. So you're getting 66. No matter how you count it, you get 66. You could also expand this guy over here. I'd hate to see you do that, but you'd get 66 terms. All right, I'll actually show you that by expanding it out, and I'll put it in the notes, by the way. Thank you.